Hey guys, this is Mrs. Harbin, and this is Pre-Cal Chapter 2. This is Presentation 2.2. We're going to be looking at linear functions. Linear just means lines, and functions are input-output. Input an x, output a y, or an f of x. Our typical application is this reminder. God made angles a part of our world. They represent a place where things come together, as well as how things are oriented to each other. Unlike lines, which are infinite, angles show God's use of a finite system of measurement. And we need to understand all of these systems of measurements in order to use the different rules and orders within math to the best of our ability. Our lesson objective is that you, the student, will graph linear equations plus find slopes and equations of lines. None of this should be new information. It should all be review from Algebra 2 and Algebra 1 in geometry. So we're going to go through this pretty quickly. Let's take a look at this example. Graph the function f of x equals 4x plus 6 with domain -6, -2, 1, and 3. Remember, domain is just your x values. So what we're going to do is take each of these x values and plug them in to our function and find out what y values each of those domain values give us. So we'll plug in -6 and get a y value of -18, plug in -2 and get a y value of -2, plug in 1 and get a y value of 10, and plug in 3 and get a y value of 18. We have our points then here before us, and we would plot each of those points like so to graph that function. If the domain is not specified, then it's understood that every real number is to be included. So we would go back to this graph and we would connect those dots and draw a line. If they didn't give us a specific stopping point left and right for a domain, then all real numbers are included. Just a couple of reminders. When we're writing the point-slope form of a line, we're writing m equals y minus y1 or x minus x1. Sometimes you'll see it as y2 minus y1, x2 minus x1. And then from here, we turn it into this equation. Y minus y1 equals m, which is our slope, times x minus x1. This is point-slope form of a line because it indicates a specific point, x and y, and a slope. These x and y values are unknown and left as variables. We can use this to find the equation of a line if we know the slope and specific points, hence the name point-slope. So let's look at this. Find the equation of the line passing through 1, 6, and 3, -1. Well, we have two coordinates, so we can use that to find the slope. And we know specific points, so we can plug that into point-slope formula. First, let's determine the slope. Using y2 minus y1, x2 minus x1, we get a slope of -7/2. We're then going to plug that into our point-slope formula to get y minus 6 equals -7/2 times x minus 1. We could have also done y minus -1 equals -7/2 x minus 3. Either one of those would work. We'll distribute that -7/2 and then put this in y equals mx plus b form. When we do that, we find that y equals -7/2 x plus 19/2. So this is our y-intercept. Y equals mx plus b is called the slope-intercept form of a line because it gives us both the slope and the y-intercept where it crosses the y-axis. Let's take a look at this function. Graph f of x equals 3x minus 2. Give the domain and range. In this particular formula, we're seeing, mx plus b. So we know our slope is 3 and our y-intercept is -2. We use that to create 2 points and connect our dots to graph that function. We know it's a function because it passes the vertical line test. And there was not a restricted domain or range. So when we're looking at this, there's no specific left or right stop values. So our domain is all real numbers, as is our range. A linear function is a function in the form ax plus by equals c, where a, b, and c are real numbers. This form is called the general linear form of a line. So we've looked at point-slope form, slope-intercept form, and now general linear form of a line. We want to make sure when we're writing in this form that we've cleared any fractions and that we want to make sure a is greater than 0. Right. X equals 5 is a vertical line. For every x value, there are just 5. X equals 5. The slope is undefined because it is a vertical line. It cannot be written in function notation. It does not pass the function test. Write y equals 3/8x plus 5 in general linear form. First, let's clear that fraction by multiplying everything by 8, and we get 8y equals 3x plus 40. And remember, general linear form has our variable terms on one side and our constant term on the other. So we move that 3x over and we get negative 3x plus 8y equals 40. And then we want this 8 term, or this a term, to be positive. So in order to do that, let's multiply everything by negative 1, which gives us positive 3x minus 8y equals negative 40. A constant function is a linear function of the form f of x equals a, where a is a real number. The slope of a constant function is 0. Okay? When y equals 7, your line looks like this. When f of x equals a number, since f of x is just y, again, you have this horizontal line. There is no slope. Lines that are parallel have the same slope and the same angle of inclination, while lines that are perpendicular have slopes that are negative reciprocals. So, just a reminder, if a slope is 2, the reciprocal of that is 1/2, and it says it's a negative reciprocal, so it would be positive or negative. The original slope is negative 2. The negative reciprocal of that is positive 1/2, and that's for perpendicular lines. Find the slopes of the lines that are parallel and perpendicular to the line that passes through these 2 points. Well, first we need to find the slope of the line that passes through these 2 points, and we find our slope to be 1/6. A parallel line would have the same slope, 1/6, and a perpendicular line would have a slope that's a negative reciprocal. Your negative reciprocal is negative 6. Today we graphed linear equations. We found slopes and equations of lines using point-slope formula, slope-intercept formula, and the standard formula for a line. We also talked about the slopes of parallel lines being the same and perpendicular lines being negative reciprocals. If you have any questions, make sure you ask me in class.